what happens in the real world is that often you become the surveyors. They'll say, oh, did you go to, yeah, and did you do a little survey course? Yes, we've done the basics. Here's a level, here's a staff. Grab that staff member over there and go and do the survey. So quite often you're actually got to do it and bring it all back into the office as well with pretty basic equipment. You won't have, unless you're in a very, very modern company and they've just scored a really big contract, you won't have a GPS unit to use, you know. You won't be walking around with the best of the best. Survey company, different. You've got a job surveying, that's all you do, they're bound to have good equipment. The next stage is they bring it back into a program like Civil 3D, which is like CAD, except for it's a 3D based program. So that you would bring it back in there and you would do some little tricks, bits and pieces, and turn it into a 3D model. And then you would perhaps pass it over to the engineers, or perhaps at that point then you may be able to do some cross sections or long sections for them from that model. So in the real world, that often happens. So as engineers, you don't have to do what you're going to do on my project. You don't have to turn spotlights into contours. But everybody's makes human errors. And no more than do human errors stick out than a spotlight that's wrong. Usually they call them spikes because they either go up or they go down. So if you've done a spotlight that's 100 meters wrong and you go to contour it, it's going to look like someone's put a great big needle through your model and one of the spotlights is way down here. Or the other way around, great big mountain. But on a less note, what if it was just a tiny mistake and it ended up making a little mound? That's where you as engineers have to sort of pick that up and go, hey, hold on, there's something a little bit wrong here. Because if you just go ahead and do the calculations, you're going to end up with way too much earthworks. When you get on site, you go, there's no mound here, where did that come from, right? Okay, so engineers tend to spend more time in the office and less time on site. Surveyors spend most of their time on site, probably the opposite in terms of proportion. So they're kind of your eyes and the ears of what's going on site. It's important that you are able to check or cast your eyes over what they give you. So we're doing these exercises this week all around contours and ways to draw them, ways to calculate them. Some of you that are good at maths, I'm just sort of generally looking around. Some of you that are good at maths will like doing this because it's not that difficult and it's mathematical. Some of you who like kind of just doing things approximately, we can also do that as well, but that involves kind of eyeballing and doing it approximately. And it's all teaching you kind of what to expect from contours. We will talk about different characteristics of contours in the lecture today, but the main thing is by the end of the lab you should be able to do your own contours on your own drawings. And everybody will be a little bit different because we're going to do it by triangulation. Also we're going to use nodes like what Ingrid would have taught you in terms of how to divide between 2 points. And well, I say we're going to, you can do it by calculation, by nodes, or by eyeballing, or approximately. And I guess your mark will be reflected accordingly. I'm allocating between 2 and 3 marks for the contours, all right? So calculation-wise, could take a fair bit of the weekend to do it. Node-wise, a few hours. Eyeballing, 5, maybe 10 minutes. So you can get an idea of what mark allocation will be, all right? We're then going to move on to do long sections the following week, and there won't be a lot of time between doing that and hand-in. I can't remember when the hand-in is, but if you haven't done your existing site plan by the time we move on to the long sections, you're probably going to struggle to hand in on time everything, because you're going to need that time from doing long sections to passing in to do your actual long section. We're going to go through how to draw the first part of the long section on in class, and we'll do the line work of the ground line, the platform, where the tree is, how to find out the tree heights, etc. But the donkey work, as I call it, of putting in all the notes and the cross references and all that sort of thing, that's the bit you're going to need some time to do, because you can't just provide a line drawing and go, well, there's my long section. So we'll go through what's required, but I'll leave you at that point to finish it off and make it look good. So part of the plan and the long section is drawing up this thing called the inlet and the outlet. And do we have a manhole? I think this semester we just got an inlet and an outlet, haven't we? I think on the plan. Has anyone had a look at it? Pretty sure we just have an inlet and outlet. So they're mirrored. So the inlet is going to look just like the outlet, except for it'll be bringing the water into the pipe, and the outlet will be distributing it away from the pipe. So whatever I draw here will be the same at both ends. So as part of technical literacy, we showed you how to do kind of 3D type drawings or isometric. And at the time, probably most of you went, is this going to be tested? And Ingrid probably said, no, there's no assignment. Yay, I don't have to really listen to what you're saying. Well, now's the time when you go, damn it, I wish I listened to what she was saying, because I'm going to do a sketchy 3D type thing on the board, and your brain has to convert that to what the long section is going to look like, and so the side view of it, and also the plan view of it as well. It's not that hard, but it's those learning outcomes that we're talking about. You can take a photograph of this, obviously, when the class finishes. We'll also do a couple of calcs today as well, in terms of just a lead into what we're doing in the labs. Should be a fairly quick class. Should be out of here before 10 o'clock, depending on how things go. All right. The other thing I just remembered, and I'll have to look up my email for it, is our past student has arrived, has landed, the Eagle has landed, and they have currently given Ingrid 3 options for a tutorial for this class. Mm-hmm. Initially, one of them was a Zoom. I've pushed back against that, because what happens with the Zoom is it's too easy for students not to turn up. What we've found with Zooms is that we get one really good student turning up to a Zoom every week, probably someone who doesn't really need it. They're just trying to push to the A+ bracket, and no one else turns up. And then in the very last week before hand-in, the whole class turns up on Zoom, and they're all asking them to pretty much do the assignment for them. What I thought would be a lot better is to try and find a time where it's not going to suit everyone, but most of you can attend, and that way you've got a drop-in class, and you can just drop in and do your assignment, and don't worry about asking them questions if you don't want to. So it gives you another space to do some work, or if you do, they're there for help. I mean, they get paid anyway, not millions of dollars, but they get paid anyway, and they can sit there and do their own work if they want to. I don't care, but I thought a face-to-face would be a better idea. All right. If you do know any of the other past students, you know, to be honest, they were pretty good at the AutoCAD side of things as well. So, you know, even though they're not a past student for this subject, they may be able to help you with some aspects of the assignment. Now just remember, they're not allowed to do it for you, so they have already gone through training to say, this is what you can do, this is what you can't do. And often they'll email me and say, look, I've got a student asking this, am I allowed to tell them what's going The way how engineering is supposed to work in all subjects is that you get a lecture, you get shown an example, and then you get an assignment, right? And then the lecturer goes, zoom. So you have to work out from their notes, the lecture, and the example, how to do the assignment. And you've already come across that on maths, physics, structures. It's kind of all the same. The subject's a little bit different because we do examples, but students tend to be asking questions on the assignment itself. Hey, I'm halfway through assignment, I can't draw this line. It is very difficult for me because sometimes that line could be marks, you know, and if you haven't calculated it yourself and I've just told you how to do it, I've just given you some marks. And it's not, you know, that's kind of like me just handing out dollar bills. You know, there is a point where I have to say, go back to week 4 and have a look at the example and see if you can work it out yourself. All right. So I'm not being rude on emails. I'm not trying to pick on anyone because they're this, that, or the next thing. It's just that it gets to a point where I have to do it that way. All right. Same with the past students. So moving on to the outlet structure, it's going to look sort of approximately like this. There'll be a pipe coming out of it, and there'll be what we call wing walls, and there'll be what we call an apron, and it's going to look sort of something like this. Most of you can get that in your head what that's going to look like. And of course the water's going to come out the pipe. The pipe's probably going to stick out about 100 mil out of the structure. So it'll just stick out of the wall about 100 mil. They don't make it flush because if the concrete moves, it can pull back from there and then we have all sorts of problems. Under normal conditions, normally these outlets and inlets just flow with a dribble of water. But of course, it's very poignant to point out that recently in Auckland, with some of the unnormal conditions, these things become torpedoes, almost like space rockets. If you think of a fireman with a fire hose blasting away, it's about that big. We're talking about a pipe that might be sort of this big, and if it's full, and coming at full velocity, it's really like a massive fire hose. So often we do, this is going to be rubbed out, but often we have these dispersers on the apron. You may have seen these before, I'm not sure. The water comes down and hits them and goes up in the air. They're designed so that the water doesn't come down and hit anything past the structure. So the structure stays in place. Now this structure, the water level can be anywhere. It can be here, it can be here, it can even be down here. So the water level doesn't, by the way, we show water level like this. It's something to remember for your assignment. Little triangle and a disappearing line. So the water level doesn't really have a bearing on the structure. So don't worry if your structure ends up below the water level in places. The critical thing is the invert level of the pipe. We'll talk about that next week when we're talk about long sections. What you do need to know is the dimensions. So when you do your ground line next week, your ground line should be, so here's your ground line, and there should be a minimum of 100 millimeters between your ground line and the top of that outlet structure. All right. So if you were looking in long section, the structure should be at least 100 millimeters below that. All right. The pipe, can we please make it the 2 times the diameter of the pipe right the way round? Sorry, what is the diameter of the pipe? It should be on the assignment. Has anyone got the assignment printed out or in front of them? Is it 450? Okay, that's actually enough. We'll leave it at 450. So 450, one diameter, 450, 450. So that's going to be 450 plus the pipe, so that's going to be 12, 1350 acrossways. And up this direction is 450, 450, but this is the bit that's unknown. And the reason why it's unknown is that you're all going to have different ground lines according to your contours that you do this week. Means that point there is going to be slightly different for everybody. There's reasons why I do that. Obviously I'm marking 30 odd drawings, and anyone who's copied somebody else is going to have very similar levels, aren't they? So it starts becoming, so if you're going to try and see if you're right, do the work yourself and ask your friend what did they get. You might find there's 2 or 3 mils difference. That's fine. You know, you've done your work, you've both done your work properly. But if there's a big difference, then somebody's wrong, or both are wrong. How far should these stick out? This angle here, in plan view, it should be a 45-degree angle. So how do I show that? I guess the pipe is coming in and the wing wall's there and it goes out like that. So that angle there is 45 degrees and that angle there is, that angle there is 45 degrees. And that angle there is 45 degrees. And how far should it stick out? Probably about the same as up there. Let's call it 1300 or 1350. So it balances it out. So that apron will be determined by those sizes, all right? Now, if you go into the Humes pipe website, Humes are the people that basically do the pipes in Auckland, Humes, and you look up outlet or inlet structures, you're going to get one that's about this size, and it'll be a specially made concrete one that will go along with a lot of jobs. But they tend to put the small ones on small pipes, so it might only be a 200 diameter pipe with a small outlet on the end. You'll not find one that's those dimensions. So this is what we call a unique or single or a one-off design, or if you like talking English, a bespoke design. So it's going to be a little bit different for everybody according to that question mark, the height. And same with the inlet. The inlet will be a little bit different as well. The levels of the apron, the invert level, the top of the outlet structure and the top of the inlet structure, all of those are very critical levels on your drawing, and you can do those. You don't need an engineer to say, hey, these are what the levels are. You don't need a, but as you can see, the height of that is going to end up being 450, that's already 900. If it goes over a metre in New Zealand, you will require a structural engineer to design So it's looking like it's going to go over a metre. So there's another note on your main, both your plan and your long section. Once again, you're not a registered structural engineer. That's somebody who's A, gone to university for 4 years, B, been in the workforce for 5 to 10 years and got registration. So they're sort of way up here, but you can say a structural engineer to look into designing this, all right? If you don't say that, then you're not doing your job. So your job's quite important. Your drawings are going to refer to us already. You know, there's the tree that could be an issue. So that's environmental engineer. There's the siltation running off if there's a storm. So you've got to protect the river, which is environmental plus Maori, iwi, local iwi, because of the water is quite special to them. You've also know that the pipe is running under the platform, so we may need a structural engineer or a geotechnical engineer to confirm that whatever that distance the pipe runs under is not going to be affected, the building's not going to affect it. And I can tell you already there's a concrete slab going there, so a bit of a note. See, the more notes the better, as far as when I'm reading through your notes and when I'm looking at your labels, the more the better. And you'll see some examples of that on some of the ones we do. And as we go along, when we do our long section, we're going to find even more things that we need to sort of tag. All right. There's also a lot of other things on this site. This is at Unitech. There's students hanging around, nosy civil and structural students wanting to go over and have a look at what's going on. Got to stop them from getting too close. We've got even nosy pukekos looking for a bit of lunch. Got to try and cage them off. We've got trucks going in and out, some sort of person controlling the traffic, might need some cones, might need traffic control. And also the last thing you want to be doing is putting mud up and down Carrington Road. That's the first. The minute that someone reports you for that, they'll close the site down until you've sorted it all out. So you may need a wash down station of some sort. Then you've got the noise. What's a good time of year to do it? I would suggest probably summer and January, February when there's no students around. Tend to have less of them getting crunched by the tyres as well as they drive past. And also the noise factor from lectures going on. And the dust factor from all the dust. So they're just things you have to, suddenly you've gone from, hey, I'm quite good at AutoCAD, I can draw a line and I can do a circle, and look at me, I can close a traverse and I passed the test and everything, to you're now drawing what I call professional drawings, and you're having to think about what's going on the paper. All right, right from the text height right through to what notes you should be putting on there. All right. A lot of people say that I mark quite hard, and I do, but at the same time, I'm very fair in terms of whoever I'm marking. I'm not prejudiced towards anybody or anyone, so that when the marks come out, anyone in industry will know that if you've got a B, that's a very good mark in the subject. You know what I mean? Whereas if you get a B in technical literacy, you're probably reasonable, but that's not a good judgment of your drawing. So these things that I talk about now in the lectures are things where you can up that mark and increase it. Ways to decrease it are your CAD skills. So all those things that Ingrid was sort of smacking you on the hand for all the time, you don't do that. That's not where your arrow goes. That's not where you start your leader. it's very important in this subject. You know, you do a very good drawing, and then I start going, no, that leader, and you don't get multiple chances. So you've got to check all of them, okay? You'll see how things go as we roll along. So today we're going to talk about, this is a little bit of a side thing. Make sure you take a photocopy of that. I'll actually do that myself. I was going to do that myself. Here it is. I was going to plug this in as well because it was dying on me as I was in the office. So at some point before you leave, we won't do it now, make sure you get a photocopy of that. And I'll take one as well, so that we when the assignment comes out, no one's going to tell me that was 12.50, not 13.50. All right? Yeah. Hello.
I'm kind of missed that part. So what was that?
That's your outlet and also your inlet. It's mirrored at the other end. So the pipe sticks by about 100. You also missed signing the last couple of people that went in. Not now, don't come up now. But before you leave class, please sign here. It's for your own benefit, not mine.
One question, please.
Yep.
If hundreds means the above the ground, right?
Or
Or the below the ground?
there's 200s there. Okay. There's 100. If you're looking at a long section down here,
Yeah.
and the pipe sticking out into here, right? 100 is the height from the ground line upwards. So you want the outlet to be just 100 above,
Okay.
right? But the other 100 is these wall thicknesses. It's easier for me to say 100. Yeah. What tends to happen is they're precast panels. They tend to do them precast. For those students that don't know what I mean by precast concrete, is they make it off site and they stretch the reinforcing and then they pour the concrete. So they bring it to site as a module, either on the back of a truck or with a crane or with a digger bucket or something like that, and they put it into place precast, because there's a lot of work in forming that and pouring it and putting the reinforcing all in that as well. So we're not going to do an exercise to reinforce it, but I'm just kind of telling you that it's usually precast. And when you go precast, I think off the top of my head, somewhere between 70 and 90 is your thickness of a precast panel, the normal thickness. But we'll just call it 100. That'll give you a note to write or a dimension to put on your drawing. Structural drawings tend to be, your notes have to be very rigid. When we do structural after the break, your structural tends to have the notes all lined up like you lined your notes up for Ingrid and CAD, right? But with civil, there tends to be notes kind of all over the place, which can look a bit messy. And it is good if you can put your notes, get rid of anything behind them. There is a command called wipeout, which can wipe out what's behind. It's a bit dangerous because you might take more out of and behind than you really wanted to. Might be easier just to break a couple of contour lines behind so that the notes are able to be read. Try not to put notes on top of things, because once you get that, it's very easy to, an I can turn into a T or something like that, and you've read the wrong note or you've taken the wrong thing. I've seen it before lots of times. I can't think of an immediate example, but yeah, and letters, numbers can be critical. If a line goes through a number and the number's 100 and a metre and 10, and it goes through the 1, it just looks like 10 mils rather than a metre. So the other thing is, and this is very important, I tend to, when I'm doing, say I'm pointing at this, and I've got 3 notes on it, on my side column, about the fact that it's precast and delivered to site, the fact that a structural engineer's got to design it, which we've talked about that already, maybe the fact that it's 100 mil below the ground line, above the ground line at the back. I don't want to be writing that all over the drawing, so I put a note that says see notes 3, 5 and 7, and then the person can go to the notes and read them from there. So that's a great way of conserving notes on the actual drawing, but it's still referencing where the notes are, all right? If you know someone else that's done this subject, it's not a silly idea to look at their drawings. It won't be the same. They'll be someone that's passed the subject, not somebody that pulled out after a couple of weeks, obviously. If you know someone that's sat and passed, and you know, they'll probably tell you, oh, Roger gave me a B for that drawing, but he was very critical because I didn't do this, this and this. They're all hints towards what you should be doing. Do you see where I'm coming from? It won't be the same, but there's when I was going through Indonesia, back in the 80s, everybody was always saying same but different. I don't know what that meant, but that's kind of what it is. They're same assignments, but they're different. Be very careful, don't copy. We had an assignment where we had a path going through it, and somebody directly copied the notes from their friend's previous one, and it said things like, be careful of the path and reconstruct the path afterwards, and I'm like, there's no path on my assignment. So I knew that all they'd done is copied the notes from the week before, you know. Yeah. Look, in engineering, I've worked in consultancies for about 20 years before I came to Unitech. That's all you do. You get a job and you go, oh, this job in South Auckland looks very much like the one we did out in Ranui out west. Hold on a minute. So you go to the Ranui job and you go, wow, same but different. There's that comment again. And you go, I can use those notes. Oh no, that's not, can't use that. I can use that. And so and the cool thing about CAD is you're just putting things on your drawing that you can use, and then you start getting the drawing together. And that's kind of what you're doing in consultancy. So you don't actually start from scratch drawing it up, you know. And then you go, oh, that's a good detail. We'll use that same detail as well. So your detail sheet becomes, you know, and that's how you build up your drawings. So I'm okay with you talking to people from previous classes and you know, asking those things. Right. Well, everyone's here, which is good. So I think we'll go through this week's notes, which won't take too long. And I think I've done a good enough lead into to contours as well. I will put this down. You'll have a wee bit of a stretch and you're ready for. Don't worry, it'll go up again. And we'll cover that afterwards. So for the gentlemen that arrived late, please sign this before you leave, eh? If anyone's here that isn't here from last week, the lab, there is only the one lab. The 8 students or 7 students that were going to go into the other lab, there's only 4 here at the moment. There might be some amongst the ones that arrived late. The lab is now on at 12:30 till 2:30 in 112 1100. Okay, so we're all together. Is that an issue?
I've got some classes in upcoming weeks that are from around 12:30.
Okay, Alright, well what we'll do is we'll organise for that to be recorded. I've got my camera lady here. She's come over especially from, what country did you say originally?
Palestine.
Palestine. She's come especially from Palestine to film these classes for us. And we'll do our best to get something up there for you to revise, alright? Is it kind of like a field trip or something like that, or a lab or something?
I think the class on Friday turns up to be on Thursday.
Just just for a few weeks?
For a few weeks.
Oh, we'll get around that, that's all right. And if you don't understand something, like, always email me and ask, okay? Yeah. And also, there'll be the extra class that you can attend with the past student in it as well, which is, takes a little bit of pressure off the filming lady. Right. So for anyone that's, we've got a few people with their laptops here, in one, two, okay. That'll mean I won't make this available just this week, so you're on the same footing as everybody else. Now you can see here where it says hidden from students. I would ignore that. Now anything that's relative to the assessments or assignments will be in here. Already there's a couple of student examples, okay? Anything that is relative to the week's notes will be under those week's notes. So it's either, if you're looking back, it's either going to be under the week's notes or under something to do with the assessment to help you. Right. There is a folder here available called Some Useful Things from Technical Literacy. It's just the divide command, and it's if you remember Ingrid's notes, some of them are really good. I don't know how many of you read through them or used them, but it's kind of just outlines how to do different instructions like dividing and dividing a line or putting nodes in places. But really you should have your own set of notes. I think they were from 2021, 2020 or something there. They still work on 2023, X Factor, etc. So they're there if you need them and you haven't downloaded hers. If you've downloaded hers, great, use those. And this week's notes. Now, is everybody okay with the lights on in terms of what you can see and can't see? You can see that okay with all the lights on? Because I can turn them off.
No.
You don't like scary movies, do you? Alright. So you'll find that when we do the notes, I just added the next section on for you. For those that already have this from last year, just be a little bit careful. I change things around and I do add the odd thing or take something out. So it's best to use this year's notes rather than if you did the course last year or the year before. Yep.
I just got a question. Because following the notes you gave to us, but the PDF forms, I think there's a car park something, is it kind of, boundary something?
I understood most of that, just a little bit at the end, I didn't quite pick up on. The PDF of,
Oh, DWG, you give to us a model, and there's a car park.
oh, you mean on the survey plan?
Yeah, do I need a hatch, like the building something?
Building, yes, car park, no.
Car park, no.
No.
Car park.
Any building or hut or anything that's would likely to have a concrete base, the concrete needs to be hatched.
Oh,
You can do the hatch, gee, this is a nice board, isn't it? If it's only showing the corner and that's all it's showing, then you can just do a hatch like that. But if there's a whole building, then you're gonna have to hatch the whole building.
Oh, no.
Okay. Yeah, with an outline.
Even for the car park, there's nothing over there, so we have to do.
Well, obviously you're gonna have to make a new layer called car park, if there
Yeah.
isn't one there already.
What about the hedge?
No, not required,
Okay.
you don't have to, no. It's an interesting one, because it's not too far away from the construction works, but, make sure you label it as car park. Yeah. We tend not to hatch roads and car parks and things like that, but we do definitely put an outline where they are, so that, I think the reason why we tend to hatch more things like wetlands and rivers and things is they do have more of a bearing on the site in terms of environmental people, iwi, everybody that's got an interest in keeping things environmentally. Trees are another thing that they like to do symbols for. Is that okay? Yeah, all right. So the main ones here are the hidden outlines of things. If there's something on the drawing that needs to be removed, I wouldn't do the tree. The tree is kind of a bit contentious, which means that if you think, at this stage we're not sure, but there needs to be a note saying that an environmental engineer to look at the tree to see whether it's going to be removed or not. So we're not sure it's going to be removed or not, but definitely a native tree should have a different symbol to just an ordinary tree. And on that subject, a 6 metre high tree, if it says 6 metre, should have a different symbol as well, because that's the limit to where you have to apply for resource consent. Heard lots of stories where people get an arborist in and they chop the tree down to 5.9 and then they cut it off. After that, a year or so later, but 6 metres is your limit before applying. Not that they wouldn't. You've got more chance in Auckland City of getting a tree chopped down slightly over 6 metres that's not native than you have in Waitakere, where they're a lot more stricter about trees and bush and stuff like that. Yeah. If you see a boundary line, just give it a little bit of thickness. Don't make it super thick, just a bit. Right click on the line in the layer, go into the layers and make that layer just a little bit thicker. And we went over the calculations last week for the sizes. Somebody asked me to do another calc as well. If you've filmed that, then I suggest if you weren't here last week to go back and have a look at that recording. You don't want to be giving me the wrong text types, all right? That's a bad mistake to make here.
Yeah, the question, because I had the calculations about the scale.
Yep.
So we convert to like 1,000 millimeters, something like that. That's we did, last week.
Yeah, 1,000.
Yeah.
Which means, what does it mean actually? I can do is like 5 multiplied 200 and equals 1,000. So.
Well, AutoCAD was designed by a mechanical engineer, and anything that's mechanical or structural, or quite a few other programs as well, is in millimeters. So basically,
AutoCAD is set up for millimetre drawings. So when we come to do structural drawings, which you have done already with Ingrid, it's easy. You just right click on the top, on the viewport, and you've got a 1 to 10, 1 to 20, bang, done. Right, everything your drawings in millimetres, so you don't have to do any calculations. You do, it'll be a different height to the scale. But when you do, and civil's the only one, and civil and surveying are the only ones that do metre drawings. And what you find is in a multidiscipline office, you'll get a structural draftsman or technician will go, whoa, not anything to do with the metre drawings, because they, in their brain, they're not sure about the XP factor and how all that works, especially a junior. And it's really hard to explain it to them.
So, which means it's like
Yep.
the most space is more 1 meter, and on paper is 1 meter. So
Yes.
we're trying to do, right?
At a scale of 1 to 1,000,
Yeah.
yeah, it depends what your scale is. As to what, if it was 1 to 100, it's a different, 1 to 200 is different. So it's, layout space is important because that's what you make your PDF. That PDF goes to the client looks at it, they put their glasses on and they go, that's too small, I want that bit bigger text, please. They don't care about model space or what's going on in model space or anything, they're just, the client's like, nah, make the text height bigger, please, I can't read those numbers. So you say, well, okay, at the moment, the text height is 3 millimetres, you can't read it, better make it 4 or 5. So you do your calc, in the model space, change the text to the right height, and the client goes, oh, that's better, I can see that now, and they, thank you, right? The client tends to dictate it. When I say the client, when you get to the council level, the councils will say, if you have to put an as-built in of how everything's finished. An as-built is a finished drawing of everything. Council want that for their records so they can pass it on to the next person that does another job. And the client will say, I want these text heights. And they're not going to say in model space, they'll say these on our PDFs, I want these text heights. If you don't do it, they just reject it. It just comes back saying do it again. You don't want to be in a consultancy where my charge out, I mean I was only probably getting paid 20 or 30 bucks an hour, I can't remember. I haven't been in consultancy work for about 18 years now, but I was getting 30 an hour. I was being charged out at $180 to $200 an hour. So if I had to spend a day on that, that's, $1,000, right? And so my boss said, you do it once and send it to council, not you do it 2, 3, 4 times. And that's just one client. So you've got council, the subcontractors often require a copy. And so the client, the council, the subcontractors, and other people will require, depending on how big the job is. The iwi, local iwi may require a copy. If it's a big job, the government or transit roading may require a copy, etc., etc. So, everybody has their own rules. So, and you know what? Councils also ask for their own colours, AutoCAD colours. You can do that fairly quickly. You just convert your own colours to theirs with a thing in AutoCAD.
Yeah, actually, my question is like, we did this conversion yesterday. Yeah, the last week, in some calculations, it's like, there's some example, it's like, if it's from 1 to 200, means 5 multiplied 200, then equals 1,000 millimeter. What does it mean actually?
It's all about the layout size of the text. So, I don't have my glasses this week, but pretend I've got my glasses and I'm really struggling to see the text height, and it's 3 millimeters high, right? So if I was a client, I'd say to you, no, I want 4 millimeters. So you go and you put 4 millimeters in your notebook, you go back to the office, and you go, well, what's the scale, 1 to 200? So I want to put this into model space, so I go 4 times 200 equals 800, but that's millimeters, right? In model space, to convert that, we have to go 800 divided by 1000, so we end up with 0.8 meters, and that's what we do in model space. Do
Okay.
Oh.
you understand?
Yeah, I got it. Thank you.
And so when you do that, and you print the drawing out again,
Yeah.
with all the 4mm text, the client's happy. He's got his glasses on, he takes his glasses off and he can still read it. Everybody's happy, right? That's why you are often asked for a layout text type before, because the client, you know, unless the client is really good on AutoCAD and they can do this, they're not going to ask for a layout size. They're going to tell you a model spot size. They're going to tell you the layout size.
Thank you.
All good. So, going back here to, sorry, this, I should have opened up week 2 now, shouldn't I?
Yes.
Yeah, never mind.
It is not available.
Not available at the moment. Well, I'm a bit reluctant to make it available to you with your laptop, because you'll look at the answer and put your hand up and ask a question before I show it. So I'll let it available to you when you've done the class exercise. There's that. So where are we up to? Week 2. So we have the week 1 notes, and at the end of that we've got week 2 notes. Okay. So talking in terms of contours. The contours, the first thing you ask yourself is what size, what's the contour gap that we should be putting on a drawing? And as a rough guide, I've got a little table here. And basically it depends on what accuracy you want the drawing to be at. So what we call a schematic is where you see on TV that they're going to do a motorway from Puhoi to Warkworth or something like that. Actually, that motorway's already there. So Warkworth to Wellsford, they're going to do another section. And you'll see a little drawing on TV of the new motorway where they're proposing to put it, the design contours and the actual contours, right? Now you're not going to do that drawing with contours down to 5mm. This is a schematic, it's a proposal, may never happen. So they may do their contours as much as 5, 10 or even 20 metres. That's quite a big height between contours, but it gives an idea of where there's going to be a few issues, where they need to build the ground up, where they might need to do a tunnel, where they might need to do a lot of cutting, digging, earthworks, and it all comes down to this. And that's why they get it so wrong, because some of these schematic drawings are not done that accurately. But hey, the person doing them is only being paid a small amount of money to get that drawing on TV. So they're limited by time. Then you have what is more of a proposal, which means you're now starting to get down to the where you actually want to put it to minimise the cost. So you might be doing a proposal drawing down to say 1 metre. Now I used 1 metre contours on a job I did for a wind farm down by Raglan. You can see all those windmills down there if you go for a drive down to Raglan, but it wasn't the ones that are there now, it's sort of the hidden ones. But we did a track on a farmer's land to get the big wind structures in place. But the farmer wanted to know roughly how much he had to move in terms of earthworks. It was only a gravel road. He also wanted to know how much gravel to put down. He wanted to know how much of his land was going to be a wee bit destroyed by the road. And the people doing it wanted to know how much to give him back for using his road as a track to get up there. He was also going to end up with free power out of it all as well, so he was on a good deal. So we did it, calculated everything with 1 metre contours. So reasonably accurate. Then you start getting down to things like minor sealed roads. So that might be a road off State Highway 2 that's cutting across to a small village or town or a settlement or some farms or something. But that's still a sealed motorway, so a sealed road, so you still need to do that down to that sort of accuracy. So the contours will be every 200. You'll note that I think the contours on the job we're doing is 0.2 as well, or 200 millimetres. And that's the sort of accuracy they would need to do a platform for the job we're doing. So it's not going to be perfect. You're all going to be doing it a little bit different. And when you come to do your volumes, you're all going to get a little bit different volumes. Once again, same but different. I think with one of my jobs a couple of years ago, people were getting like 11 cubic metres, 12 cubic metres and 13 cubic metres, around about that range. And my A students were just about crying because they couldn't get close to each other in terms of their calculations, but in reality they were all right. They were all doing it according to their contours. So that's giving you an idea of the inaccuracy of earthworks sometimes, right? You can, in the office, I can sit there, come and water my pot plants, get a finger cut from paper every now and then if I'm living dangerously, but on site it's a different story altogether, right? And those guys and girls on site have got to fix those issues, you know, and they grumble the whole time, who the heck did this back in the office? I bet you they're just sitting all there all day having cups of tea and doing nothing right, you know. So you're not the most popular when you arrive on site to have a look at your job, but there's a bit of friendly rivalry. You learn more if you become a site engineer if you're doing site engineering into a couple of years than you'll learn ever in an office. So you'd be very valuable if you came back into an office having done site engineering. But you do have to put up with all the BS going on site, and by that I mean, you know, grumpy digger drivers, guys just disappearing, not turning up for the day, all those things that are associated with the people that work on site. You know, you're in charge of health and safety and someone's just walked straight through the area you told them not to. You know, you have the power to shut the job down, but yeah, it's kind of, you're crunching with them every day and trying to be mates as well. So it's a difficult job. And of course, the minute it turns to custard, the digger drivers, the truck drivers, the foreman, they all go, not my fault. And they point to the engineer that's sitting in the site office, right? So, and they're reading the plans going, what the hell, someone's made a mistake back at the office, right? So, yeah. So the accuracy of the drawings is important to a certain point. But then when we get down to things like tennis courts, bowling greens, or even the outdoor eating area down at Unitec, we need to start getting down to sort of like 5 mils in accuracy. And you're probably going, why? Well, first of all, with a bowls court, you don't want the bowls going off on an angle, you know. With a tennis court, you want to play on a fairly flat surface. You don't want to be on the side when you're playing. But more importantly, like a courtyard, when it starts raining and everyone decides, oh, we'll go inside, you don't want that to flood and end up a swimming pool that you can't use for another week. So you want the drainage, if you're doing it to 5 mils, it'll drain away. So So you're out there playing tennis the minute the sun shines again, or you can go and eat your sandwiches without, like me at the Elton John concert about a month and a half ago, I'm knee deep in water just to get a drink and some food. I've actually got pictures of that. I won't post that on the site. Yeah, Mount Smart Stadium. That's the drainage out the back. Just turned into a swimming pool. I know it was a rare event. The coffee cart was floating away. There was two Chinese guys selling coffee, and they were still trying to sell coffee, and the cart was floating away. I know. Yeah. So you had to wade through, and you imagine the queues like at Eden Park when you go to rugby. There's queues everywhere for food and beer. There was queues, and people were up to their knees walking through to get with their food trays and their drinks, and then they had to pay for it on the F-Post. I dropped my F-Post, it went into the water.
Oh.
Luckily it floated. So yeah, so you don't want that happening on a courtyard. You want everything to drain. You want everything to drain nicely to where you've put your drain holes. And you'll find that when you go into the real world and you're doing a real job, let's say you're doing a housing development, the most important thing to do first, before you start getting all your other levels right, is to make sure your drainage works. You've got the right slope on the pipe, and the very last bit of drainage works properly. All right? Some of these places that flooded, the biggest problem was that it wasn't the fault of the new developments, it was the fact that they were taking the water into areas that were old areas that were only designed for that area, and they all blocked up, which meant that the new development water had nowhere to go. So it just went everywhere, because manholes are designed to pop, and then the water just comes up through them. So I think things are going to change in Auckland a lot. You won't be able to do a development without there being a proper way to let that water go into a system that's going to hold it, going to handle it. But anyway, that's side issues, but I'm just saying that that's usually the first thing you have to do. Same with roading. If you're going to put a road from A to B, first thing you want to know is where's the drainage going to go off the side of the road, where's it going to go, what size pipes, etc. I don't know who did the drainage for the southern motorway when it flooded. So I live in New Lynn. It took me 2.5 hours to get home from the Elton John concert. Not when they said now you've all got to leave the stadium before it was cancelled. I had to wade through knee-deep water to get to my car. Luckily the car was parked a little bit uphill, and then we took 2.5 hours to get back to New Lynn, which is normally about a 15-minute drive.
Yeah.
There was just everywhere, people's houses flooding. It was an interesting night. Good old water flow. So when you come to the scales of drawings, please take note of this. There is a question in the test on scales of drawings. You'll notice once again with civil drawings, we tend to use 1,500, 200 and 250 sometimes. 250 is not in there, but it is another common one. Obviously 1 to 10, 1 to 5 and 1 to 50. The bigger the number here, the bigger you're zooming in on the drawing, and you tend to use the bigger numbers, or the smaller number scales, but the bigger drawings for areas where you're trying to get your design right. Contours have different characteristics. If a contour is uniform in slope, so for example, you're looking at a plan and a contour is like this, usually that means that it's been man-made, so it's an even slope, and that is what's going to come off your platform. You're going to have even contours coming off your platform, which will be man-made. They're either going to be fill or they're going to be cut. All right. If a contour looks something like this, so it takes a sharp turn and goes like that. That means that it's a peak. It's going up on the peak of a mountain, but it can also mean that it's in a valley between two mountains, so a valley or a peak. A contour, if the further apart these are, the flatter the ground. The closer they are together, if you're reading a plan and you're in the middle of nowhere in the bush, don't go near it. There's a good chance there's a straight drop, because the contours are close together, meaning it's a cliff. All right. So you've learned something now. If you're in the bush reading a plan, not with contours on it. Generally speaking, contours will always close on themselves, but they may not be on that drawing. You imagine if you're doing a drawing of Unitec, contour might take off at the end of Unitec and head towards Mount Albert and go around the mountain, back out the other side, over by Newland, back over here, and then it might join back on at Unitec. It does join back on itself, but you've only got a snapshot of one area, so it goes off your plan, never to be seen again. So all contours will eventually join upon themselves. There are situations like on Mount Eden where it's a volcano, where the contours will go up and then they'll go down again, which is rather odd, but that can happen from time to time, where it goes up a bit and then it comes down a bit. And also they cannot cross each other. The same contour cannot cross each other. There's one exception. If you've ever watched the movie Cliffhanger, I think still Phil Sylvester Stallone hanging off a mountain there with a precipice like that. If you've got a precipice going slightly downhill, they can cross over, but that's about the only exception that I can think of. There is a question on that part in the test. It's worth revising again. Now, what I call three methods. There's the estimation or eyeballing method. We're going to do a class exercise of that, which will be filmed in 112.1100. So what will happen is I'll give you something to look at on AutoCAD and to have a bit of eyeballing or estimation, and then I'll show you how I do it, and then I'll show you the answer, so you can compare your answer with the answer that is there. You might find that you're actually quite good at that, and it might be one of your options. What a student did one year is they did a bit of everything. They did some calculations, so they knew some of their lines were perfect. They did some graphical with nodes like this, and they did some by eyeballing, and they actually got the full marks out of me. They fooled me that they'd done it properly and graphically, right? So I thought, how am I going to stop that? So if you do it by calculation, leave your mark on there where you've calculated how far along the line the contour should be. So put a little cross or something, or a little mark. If you do it by nodes, leave your nodes on there, and then I'll catch you if you try and do estimation. It was really annoying because I put my thing on top and it was perfect. So, you know, perfect marks. The student said, oh, I only spent about half an hour on this project. So what the whole idea of the nodes is you're given a level at A of 51.5 and a level at B at 50.6. Now, if you do your points there, there's going to be 50.7, 50.8, 50.9, 51, 51.5, and so on. There's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 between them, right? So you divide by 9, the nodes come up in red, and then you just simply count from A backwards 5. 1, 2, 3, 4, 5, and that's your 51. That's as simple as I can put it. So between these two, you've got 0.9. So my decision there was to divide that by 9, and I just came back 1, 2, 3, 4, 5, and that's exactly where the 51 mark is. In the lab, if I don't do it, remind me, I'll show you how to calculate that exactly. You do need the CAD length when you do it by calculation, because you'll have to put that into your calculation. It's a proportional thing. So I haven't shown the calculation method yet, but what I will do is give you a little bit of class exercise to do just before we finish up. So can you please do 3 squares, 3 crosses on your piece of paper? One is 100, one is 97, one is 95. And I want you to draw where the 99, 98, 97 and 96 contours go. That's all you have to draw. And I'm going to roll down the page in about 3 minutes time, so that's how quick you get. I'll give you 3 minutes. And we'll actually I'll have a look at my email.
96在97跟95中间的，大概意思。
I'll show you the answer to that in a second. I've got more of these coming up. Okay, so for the tutorial, we have, it can be for an hour, it can be for 2 hours, depending on who can and can't make it. You all know your timetables, and some of you obviously have got part-time work as well, so some days won't work. They're probably not going to be able to cover everything. Show of hands in terms of numbers for Monday 1 till 3. Does that work for anybody? Not a good one? works for you. So we've got one. Does it work for anyone else? Can you see that there? Sorry, can you see that? So I mean, like it can be, for example, that can be 1 to 2, or it could be 2 to 3,
但是
and that
1
could
点半
be
结束，
that could be
我们晚
10:30
点去啊，我们晚点去
to
啊，
11:30,
那我们去后半
or
段，
it could be 12 to 1. That could be 3 to 4, 4 to 5, or 5 to 6.
我星期三我不行，
So could this time zone work? At the moment, we've got one student.
那就
1, 2, 3, 4, 5, 6.
1:30, yeah. After 1:30.
1:30.
One after 1:30, we can do it.
yeah，可是
So more like a 2 to 3 one.
Yeah,
Yeah.
yeah, 2 to 3.
2 to 3.
Yeah.
Okay, yeah.
They have lunch service.
1, 2, 3, 4, 5, 6. Does that work for anyone else? 7?
2，对2点2点吃个饭，
Does this work better for anyone else? We've got a no there, we've got 1. Anyone else? 2?
Nah, we are too busy on Tuesday.
Study. Yeah, too busy.
Too busy.
Wednesday? Any time there? Works well for the chap at the back. 2? Anyone else? 3? Down?
周一吧，
4?
周一都有空吧。
See, for somebody that some don't want tutorial law. Okay. Well, it's looking like a Monday 2 till 3. Oh, actually, you said 1:30 till 3, didn't you?
2 is fine. 2 is fine.
2 is fine. 2 is better.
Yeah.
We have time to eat
Yeah,
lunch.
we need a lunch break too.
Wednesday was 4 people. Hold on, can you put your hands up a bit higher then in that case? For Wednesday, oh, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh no. Okay, anyone else? Anyone else want to increase? I'll go Monday again. Anyone else want to? Anyone else want to do Tuesday? No. Oh, I'm sorry about that. The Monday ones, we just got outvoted. And wonderful. Now, what the issue here is? It's only is yeah. Which one we between 3 and 6? Do you want to split the middle and do 4 to 5 or what?
4 to 5 would be good.
Yeah, that's for you. But what about the others that put their hands up? 4 to 5?
3 to 4 is better. I have to pick up my
Not
daughter.
3 to 6. Not 12.
3 to 4.
I'll tell you what I'm going to do.
4 to 5.
I'll tell you what I'm going to do. I'm going to go 3 to 5 and ask if we can do a 2-hour 2-hour one, which will give everybody an opportunity to pop in that can. Apologies if you're in the minority. I feel like I'm being mean, but if somebody could perhaps record that.
Yeah, please record it.
Oh, hello. Yeah, or even you could. I'm sure that the thing is that when you go to a tutorial, you can ask things that you might not want to ask me, for example, and you might be feeling a bit freer to ask questions with
Another student.
another student, right? You know, you can say things like, "Oh, yeah, Roger's pretty mean," or "It's hard," or whatever. You know, you can't.
Do you know who will be class leader with us?
That'll be your secret surprise, I think. I think we're talking about this afternoon. They're going to make an appearance. They're doing their training at the moment. So, yeah. Okay. Does that make a difference or no?
All I can tell you is we always organise for somebody that's got some experience and was quite good at this subject, either this one or the degree one. It's very similar. Yeah. So 3 to 5, we'll make sure it's recorded. Ask the questions that are that are difficult for you. See what they can do. Sometimes they'll come in and they'll do a standard class where they'll go over something. Once you get their email, you might be able to say, hey, in class, can you go over such and such? Cameraman can film it, chuck it up onto YouTube, and you've all got a wee bit more help. All right? For those that can't make it, I'm going to put the first link up on YouTube. If you're putting it in the same area, then we can, you should be able to find the next one after that. You give it a logical name of some sort. Okay? Now the answer to this, and I know it's getting close to time to take off, but I'll be pretty quick. The answer to this is to very quickly divide these areas off. All right? You can do that very quickly in your own head without having to get out your calculator. And then, of course, when you've done that, you join the dots up, basically between them, and you end up with something like that. See, the blue lines are. So in this next one, I've made it a little bit harder. There's 4 of them. I'll give you 2 minutes. But we need to find the contours every 0.2, which is a wee bit more similar to what you're doing in your assignment. So you've got odd numbers there.
Well, how do we do the calculations?
I'll show you a calculation, and it's to do with the length of the length, and so when you've got a length of you've got 2 points there, right? So you draw, if the height of that is 100 and the height of that is 95, that distance there becomes 5, right? So that's 100 up there, and that's 95 down there. And you're trying to find the contour of say 96.5. So you want to know how far along there it is, and it's all to do with that distance. So say that distance there is 20, and you know that the distance between the height difference there between there and there is 1.5. So that height is 1.5, right? That's 20. And you're trying to find out what x is. Right? You wanted to try and find out what that distance there is. X. So you have one triangle, it's equal triangles, by the way, which is kind of like your first year of maths here. So you've got 5 height and you've got 20 long. You've got to convert that to 1.5 over there. So you've basically got 2 triangles. One is 5 and 20, and within that you've got one that's 1.5, and you've got to find out what x is. So it's 5 divided by 20 equals 1.5 over x. Solve for x. And that'll give you the distance. Same calculation for everything, to work out where the contour. Wouldn't matter if that was 65.56,
because that would end up being 1.56 there, and it's still the same calculation for X. But if I get the chance in the lab, I'll do a proper one, but you'll see that. But you can imagine if you've got 3 contours coming through here, the calculations you have to do become pretty wild. Yeah, and especially when you've got you've got to draw triangles on all of these and work out each point. Nodes become a lot easier. See, for example, between there and there, I'd do 3 nodes, because it's 0.5 and 0.2. But if that was 20 and 50, I'd do 30 nodes. And then you just count the nodes. Yeah. Anyway, 59 we're up to. So that's how I did this one. I divided the sides off, and I divided that off. And then instead, every second one, I did the contours. See that? I know it's simple, and there's your contours. You've got 2 numbers, not just 1, but it gives you an idea of how I break it down. So we're going to do an eyeballing one in class. I'm going to show you a calculation in class, and then I'm going to show you how we calculate these formation contours, which you won't have to do to assignment 2. But it's really important that you turn up to that, because that's worth some good marks in assignment 2. There's quite a bit of learning outcomes at 12:30 today. Make sure you sign that piece of paper that's going over here.